Okay, so Sean, I'm referring to you as Dr. Sean Pitman. Tell us a little bit about yourself. What flavor doctor are you? Where are you from? Are you married? Just kind of give us the sketch, the trailer view of, or the trailer version of Sean Pitman.
Yeah, I'm a pathologist here in Northern California in Redding. And so a pathologist basically tells surgeons what they took out, like, sorry, but you can't put that back in sort of thing.
Gotcha.
So that's most of, and I also have a subspecialty in blood and hematopathology.
Okay.
So I run blood banks and lymphomas, leukemias, things like that I diagnose as well. So I took a subspecialty in that. And so it kind of helped in my my understanding of this whole creation evolution, because it kind of heavily emphasizes genetics. And that's where I started in my own walk. I grew up in an Adventist pastor's home. My dad's a pastor, my mom's a nurse. And so I have a lot of background in heavy Adventist culture, I guess. I mean, I sat in the front row for the first 16 years of my life.
Are you telling me, Sean, that you're a dreaded PK? Is that it?
Yeah, the wild, horrible PKs that you always didn't want to, that you always laughed at and everything. Yeah, that's me.
So were you a wild and horrible PK, or were you more well-behaved?
I had my moments, but I wasn't the worst PK I know of. I hope not, but I had my moments. I got suspended twice in high school, and I did my share. But
okay,
I still would never. I never went completely like wild and left the church or anything like that. I still always believed. From early childhood, I believed that the Bible was correct.
Okay.
I just always had my questions, and especially evolution, Darwinism, and creationism. I had a lot of questions that never got answered growing up in a pastor's home.
Because your dad's a pastor and a preacher. He's not a scientist or a biologist.
No, my mom's a nurse. They
okay,
tried.
fair enough.
To be honest, though, even when I went to school, high school, college, even through medical school, and the professors I talked to, the biologists, the scientists I talked to, they still didn't answer my questions in a way that I could understand myself.
That you found satisfactory.
Right. They still had their own questions, even at very high level. And so I, at some point, it wasn't until I got through medical school and I went to the Army because they paid my way through medical school.
Okay, as they do.
Yeah, so that was really handy, actually. I love the Army. I really enjoyed my time in the Army. I got a lot of experiences there.
You were in 4 years? 5 years?
In 4 years, yeah.
Okay.
Active duty 4 years, and then another eight years inactive.
Now, just quickly before you talk about the Army, do you have brothers and sisters?
Yeah, I have a younger brother, Shannon, who also went through medical school with me at the same time. It was really frustrating being the brother of Shannon. He's one of the, people I can count on my one hand who's got pretty much almost a photographic memory, like a semi-photographic memory, where they can remember stuff 10 years ago. Remember that on paragraph, page 358, paragraph 2, remember where it talks about the Krebs cycle, the second element? I was like, no, mercy. I don't remember that at all. So anyway.
So I guess that's your way of saying that he had an easier time in medical school than you did.
Oh, way easier. I had to really struggle. It's miraculous, I think, getting through medical school for me.
So just one brother?
Just one brother, yeah.
No sisters?
No sisters, no.
Okay. And so raised in a Christian home, obviously a devout Christian home. Dad's a preacher. Your brother, you said, is younger or older? Younger.
2 years younger, yeah. But they always thought we were twins for some reason. I don't know why.
Okay, gotcha. Did he go into pathology as well?
No, he went into general surgery, but then he decided that wasn't for him. So he's now in family practice in Georgia.
Okay, gotcha. Okay, so now let's catch back up. So you have a lot of questions just about the nature of faith. You're sort of growing in your understanding, and you're saying that a significant percentage of those questions that you had for mom and dad and probably other pastors or people of influence in your life as well sort of centered around, what about creation? What about evolution? Was that a particular area of sort of interest and even stickiness for you?
Yeah, it was mostly ignored growing up. It
Okay.
was just taken for granted that the Bible is true and that some of these questions are just too difficult to answer this side of heaven, basically, and that no one really had great answers for why are there a bunch of different kinds of roses and different kinds of cats and dogs, and where's the limit? Where does evolution, you can see these changes, and there, yeah, you can see lots of things change over time. Well, where's the limit? Why can't
Okay.
you say, well, it comes to this far and then it can't go any farther? Well, why not?
Mm.
Well, because the Bible says so, right? And so, and when I got in the Army, that just wasn't good enough, especially for people who are my friends, good friends of mine, who came from completely secular backgrounds, who were saying, hey, you're a physician, you're a doctor, you're interested in science, but how in the world can you be a Christian? Because that's just fables, right? The
Right.
Bible, because the Bible says so, just doesn't cut it. When you're talking to somebody like that who has no biblical background whatsoever, you're like,
They're not
asking
invested in
you all these hard questions, and you're like, well, I don't know, right?
Yeah.
And that's not really a good position to be in, for me especially. And it got to the point where I got so frustrated, and I got really scared, actually, because I felt if I looked into it and I found out that the Bible just wasn't scientifically credible, that I might have to leave the church. And that's really hard for a pastor's son,
Sure.
to take, because my whole life has been in the church. But I got to that point. I was like, well, I was really scared starting to look into it, especially the genetics, because what if I found that the Darwinian mechanism, random mutation, natural selection, what if I found that was actually credible, that there was no cutoff point, that you could actually evolve from a lizard to a bird, or something like that, some major evolutionary step? What if I could find that the mechanism could explain that? And I was like, well, for me, I just, it wouldn't be consistent anymore to stay in the church, much less become a Christian.
So just a question about that. So obviously you're going through what sounds like a little bit of fear and anxiety, like you want to know the truth, but you're at least a little bit afraid that if you find out a truth that's not easily harmonizable with Scripture, that you're going to have to make a choice.
Right. Yeah, if you want to be honest with yourself, because I know people who kind of try to do both things. And for me, I couldn't do that. I know some scientist friends of mine who are Christian on the weekends, but then during the week, they're just scientists. And they say the two worlds never come together. They never mix. But for me, it's like, my worlds are all the same world. I want to live in one world, right?
That compartmentalization wasn't going to work for you.
I don't want to be schizophrenic,
Right.
So I was very nervous starting out. But they pushed me so far that I had to come back and say that I at least looked into their questions, but I was nervous up front looking into them.
Okay, so this is happening when you're what, mid-20s? Is this after medical school? So this is after medical school, you're in the Army, so you've got to be what, late 20s?
It's my late 20s, 28 or so.
Now, I want to circle back and get into some of those questions, but before we do that, Sean, was there a moment, or maybe a series of moments, or a series of discoveries or realizations that you had that settled you into, wait a minute, no, the Bible is teaching the truth, and creation was recent, and it is to be taken literally, and there was a global flood? Was there any moment or any single thing that happened or realization that occurred that sort of settled you, or was it progressive?
It was a little bit gradual over, I would say, a couple, 3 years. But I did start to get excited early on, because the first thing I looked into was genetics and to the Darwinian mechanism, random mutation, natural selection. And for me, a lot of people it would go over their heads. But for me, that's where I started, because that's where I was most familiar.
Okay.
And when I started finding out that there were distinct limits, like actually, it was helpful for me to discover that the Darwinian mechanism actually was capable of doing some things. It did explain, there were some evolutionary changes that could be explained by this mechanism, that it was powerful to a certain degree to explain changes in plants and animals. But what I really got excited is that I started to discover that this mechanism started decaying in an exponential way as you move up levels of functional complexity.
Okay.
Like what Darwin looked at, and a lot of evolutionary friends of mine look at, they look at very low level evolutionary changes like random mutations, producing antibiotic resistance, or
Okay.
producing color changes like going from a brown rabbit to a white rabbit or something like that. And so as I started looking at the actual mutations involved to create these changes, it's like, where are those on functional complexity levels? Where are those on the ladder of functional complexity? How many mutations are required? What's the size of the protein that's involved? What's the size of the overall mechanism that's produced? And so when I started looking at that, I started noticing a pattern that all these examples of evolution in action, for one thing, either weren't examples of evolution at all, like a lot of them that Darwin discovered or wrote about weren't evolutionary examples at all. Nothing really evolved that's new within the gene pool. What happened for a lot of his examples are really Mendelian variation. They're pre-coded, pre-established options in the gene pool that are already there. And then as you recombine genetically through sexual recombination, that different traits are sorted out in different individuals that then highlight those traits and express them. But those aren't really new within the overall gene pool. Nothing was added or nothing was taken away. So for me, that didn't really count. Those aren't real examples of evolution in action.
Okay.
So
you're saying that, just so we're clear, I mean, I think we all remember what do they call the squares? The Mendelian
squares.
The Punnett square. Yeah. So you're basically saying a lot of the variation that Darwin was detecting were not like evolutionary changes that were in a trajectory, that were in a sequence, that were headed somewhere. They were just the showing forth, the manifestation of the genetic information that was already in the genome.
Yeah, it's like highlighting different spots of the genetic pool. Like, okay, we couldn't see this spot before, but this creature highlighted it, but it was there already. We just couldn't see it.
It wasn't novel. It wasn't created by evolution.
Right. It was already there. It just wasn't seen yet. But the parental gene pool already had access to that information.
Okay, let me back up let me just back up a little bit and ask a series of questions to set this conversation up, Sean. So first of all, we're talking about Darwin, and you've mentioned several times now random mutation and natural selection. Just give us like the very brief sort of introduction. What was it that Darwin discovered, or what was it that Darwin thought he discovered, and what did people believe up to, say, 1858, or his journey on the HMS Beagle to the Galapagos? What did people believe before Darwin?
They believed that everything was static. They believed the Bible. Even great scientists most of them were Christian.
Okay.
And they believed the Bible and that God created every unique, distinct kind of species and that nothing could change it. It was static.
Okay.
Nothing could move at all. They were very limited in their thinking of how to describe a gene pool or how far it could go or how it could be modified. It wasn't until Darwin came along that said, no, these things can change. Look at all the different kinds of finches, the different finch beaks on these islands, and these different kinds of plants and moths and dogs and cats and whatever, you name it, everything changes over time.
So Darwin is noticing variation within a species, and then he creates or comes up with a hypothesis that there's a trajectory here from lower levels of complexity to greater levels of complexity. Is that correct?
Yeah, he noticed changes, and so he said, maybe these changes are not stoppable, like there's no boundary.
Okay, no limits.
No limits. One thing can easily merge into another given enough time. If you have a few million years, anything can change into anything else.
Okay.
That's what Darwin's novel idea was. So there were no boundaries anymore that had been there in the minds of scientists before Darwin, that there were these static, very rigid boundaries. Nothing could go beyond that.
Almost like divine limits to adaptation within a species.
That's right.
I mean, certainly people knew, like, for example, with the breeding of horses or of dogs, that you can make really big dogs or really small dogs or really hairy dogs or dogs that have less hair, fast horses, large horses. They knew that there were this genetic information in a given genome that could be exploited, but they just thought that these were rigid limits.
Yeah, rigid limits. And they didn't even know how that worked. It wasn't until Mendel came along.
Right.
Gregor Mendel. Gregor Mendel and Darwin lived at the same time, however.
Okay, they were contemporaries.
They were contemporaries, but Darwin was not aware of Mendel's work. Mendel was aware of Darwin. Yeah, Mendel was aware of Darwin's work, but Darwin was not aware of Mendel's work. And so Darwin became famous before Mendel. And it's one of the reasons why I believe that Darwinian evolution really took off. Because let's say Mendel came first and he actually became well known and famous before Darwin came on the scene.
Okay.
I don't believe we would be here right now having this conversation.
Really?
Yeah.
So you think that Darwin, if he would have been familiar with Mendel's work and would have known about this different expressions of information that's already in the genome, he would have just attributed it to Mendelian variation. He wouldn't have looked for something else.
That's right. In fact, because most of what Darwin did cite as evidence for his theory was really Mendelian variation.
Okay, so
there's there's very little novel that Darwin cited actually that can't be explained by Mendelian variation. It's just that Darwin thought that something more was going on when really nothing more was happening. It's just Mendelian variation.
Okay, so Darwin publishes On the Origin of Species in 1858. I'm assuming that the microscope technology and the availability of information about like what we know today, what we take for granted with genetics, was very rudimentary if it existed at all. What level of technological development did Darwin have to go on with regarding like microscopes and or even just an awareness like we know today about DNA? Did he know any of this?
No, they had the idea that cells were just little blobs of protoplasm. They had no real complexity to them. They just helped the human body stick together, basically. They didn't think of them as little tiny factories like we know today, that they're like complex as major metropolitan cities. They had no idea, not even the tiniest grasp at what was happening inside a cell, certainly not genetically at all. And so Darwin just assumed that all these phenotypic changes, these changes in physical appearances of things, that those were endless because he did not understand the machinery behind it.
So the discovery of DNA takes place in the late 1950s, Crick and Watson. Am I right about that?
Yeah. And Crick and Watson, they're both evolutionists as well, because Darwin became so famous, it was almost like a dogma, a mantra that this explains everything in biology. And so even when genetics came along and the discovery of genes and how they work, I think the philosophy was already so ingrained by that point that it was hard to challenge.
I mean, at this point, that's a great point you make, that Darwinism has really seeped into every possible academic discipline. You hear about Darwinian economics and Darwinian sociology and even Darwinian cosmology. I mean, I've heard, is there any area of academics that has not been touched by the sort of,
well, it was kind of the first step towards secularism, like that God is not needed.
Correct.
In this major area of science, where before it was felt that God was needed in every area of science, that God explained everything. Now, all of a sudden, Darwin comes along. And so this major area of science, living things, God is not required to explain them or their diversity. Right. And so that kind of really gave a big boost to secular thinking in every aspect of science. And part of the reason why Darwin went down this road himself, because, he started out he wanted to be a priest.
Yeah.
In the priesthood.
Started off in ministry.
Right. And so what really tipped him over the scales is that he saw a lot of evil in the world, in the animal kingdom, and even in the human experience, because his own favorite daughter died of scarlet fever.
Right.
And that kind of really psychologically affected him and tipped him over the edge. And so he decided if there was a God, he really wasn't worth knowing. And maybe he just stepped away from the world, even if he started it off. But he really clearly wasn't involved, because if he was, he would have to be evil. Right. Otherwise,
because a lot of the versions of Christianity, or the version of Christianity that Darwin was railing against, was a very deterministic, Calvinistic version of Christianity, where everything that has happened is foreordained by God and will eventually redound to His glory. And Darwin, I think very correctly said that if that kind of God is the God, that's too irrational. In fact, I've read several quotations to that effect where Darwin effectively said, this is irrational and unbelievable. And so he started looking for another mechanism whereby the incredible, diversity that we see in the world today, biological diversity, It had to come from somewhere. And if it wasn't God, well, then there had to be a mechanism.
And also the mechanism he came up with was amoral. It wasn't good or bad. It just was.
Right.
Right. It's just like a fact of nature that it had no morality behind it. It wasn't like God being evil to you.
Mm-hmm.
It's just like, well, I'm sorry, this is just the way things happen. They just evolved this way. There's no good or bad in the world. It just is, and so.
And that was the idea of natural selection, what we sometimes refer to as survival of the fittest.
Right. So even though survival of the fittest takes advantage of the weak in favor of the strong, it's really has no moral implications because there's no intelligent mind behind it.
Can you just give us the, again, trailer version of what are we talking about when we say the survival of the fittest or natural selection? Did Darwin actually coin the term survival of the fittest or natural selection, or were those later, was that nomenclature sort of added later?
I think the survival of the fittest term was added later, but his concept was that things can improve over time because of fitness, improved fitness. They help survive long enough to make more offspring. Was basically Darwin's basic idea.
Okay.
And what happens is that tiny little changes, infinitesimal changes, can just add up over time that are more and more fit as far as a level landscape is concerned. You've got this population of zebras or whatever, and one of those zebras has a tiny little bitty change that makes it slightly more fit, able to reproduce more or survive longer in order to make more offspring.
Okay.
And so then that particular descendants from that particular zebra takes over the whole population. And so you raise up a level, and then you go up and up and up and you never stop. You always improve, always improving over time.
And this is the idea that there are no boundaries, no limits, and given enough time, I mean, really time is the hero of the story, right? Because given enough time, nature will select those that are the fittest for a given environment and the most likely to reproduce. And so time is really the hero of the story. Is that fair?
Yeah, given enough time, time creates the miracles. Everybody, even Darwinian scientists, even atheists, believe it's kind of miraculous what we see in the natural world. But they believe that the miracles are created by time.
Okay. So you mentioned earlier that the Darwinian mechanism is random mutation and natural selection. Natural selection was Darwin's idea, but because he didn't have an awareness of genetics like we do today, post Crick and Watson's discovery of DNA, he must not have understood the idea of random mutation. That's been an add-on then to Darwinian evolution?
No, he had kind of a concept of mutations. He just didn't know what was mutating.
Okay, gotcha.
He knew he didn't have the concept of DNA or genetics, but he knew there were tiny little changes that were random.
Okay.
Right. And so he says some of those changes, however they're happening, which he didn't exactly know, they just add up over time and make the creature better.
So cumulatively over centuries and millennia, we're not just getting more well-adapted zebras. Zebras are on this sort of fluid trajectory of come from something and going somewhere. There are no limits.
That's right. Yeah, they came from tiny little single-celled bacteria originally, and zebras will maybe end up, building spaceships and traveling to galaxies far, far away.
Okay, so on that, this was one of your questions as a preacher's kid, as a young Christian. You were saying, okay, wait a minute. Why are the examples that are often given in favor of Darwinian evolution, why are they these very low levels of functional complexity? You talked about things like color change, antibiotic resistance. So let's talk about that a little bit. It is true, isn't it, that random mutation and natural selection can explain a significant amount of what maybe interspecies variation? Is that fair?
Oh, yeah. And even what people like species definition is also kind of vague.
What is a species?
Exactly. So there's different definitions of a species. The species are basically an interbreeding group, but there's some different animal groups that are different families or different orders, and they can still interbreed and make viable offspring.
Okay.
And yet they're classified as different species and even different family groups and different orders. And so there's lots of examples of these. And so you're like, well, where is the the true biologic definition of a species. And I kind of ended up favoring more and more the biblical description of kinds, because the
Okay,
Bible
unpack that.
described this kind of animal and that kind of animal. Like, for example, all cats, I believe, are the same kind of animal, and horses and zebra are the same kind of animal. Even though they're classified today as different species, you can breed a horse and a zebra and make a zorse. And
Is that true?
That's true.
Okay.
They can make a little baby zorse, and it's a combination of zebra and horse, and it lives. It's viable. It happens.
So would you say the same about like jackals, foxes, wolves, coyotes, dingoes? Those are all the same kind of animal?
Yeah, same with house cats and lions. They're the same kind of animal. Like, I believe before the flood, there was only one type of cat, basically, or maybe a handful of cats, and that they could all interbreed. They're all the same kind of animal.
Okay.
But then, based on the original front-loaded information of that gene pool, you can go all the way from Chihuahuas to Great Danes, all the way from house cats to, South African lions, right? There's a huge variety that God front-loaded into these creatures.
Okay, unpack that. When you say God front-loaded it, I love the sound of that, because it's got that sort of, Jesus is the Word, He's the Logos, He's the information. Unpack that a little bit. What do you mean by the front-loading of information into the gene pool?
Like, for example, we can see it in real time. Like, take dogs, for example. All modern dogs, from the Chihuahua to the Great Dane, all descended, we know this in real time, modern time, in the last 300 years, starting with the wolf, right? So you got this wolf, you can breed out in this wolf gene pool. In that gene pool, front loaded is the information for the Chihuahua and the Great Dane, right? And everything in between, hundreds and hundreds of breeds, right? And they happen. So my friends, when I brought this up to them, I was like, Sean, you're not a creationist, you're a hyper evolutionist. You believe in evolution. You believe in evolution, not slow evolution. You believe in extremely fast evolution. And I was like, that's right. I do believe in extremely fast evolution, because it's not evolution. It's Mendelian variation based on front-loaded information. And
so let me ask you about that. So from a very small Chihuahua to a large Great Dane and every breed of dog in between, you're saying all the data that's necessary to make these different variations, big dogs, little dogs, hairy dogs, hairless dogs, it's all in the gene pool, and all that breeders are doing, not natural selection, but purposeful selection, they're just exploiting those characteristics that are there. No new or novel information is being created by the breeding. You're just tapping in to what's there. Am I getting it?
For most breeds of dogs, that's correct. There's some breeds of dogs, like with the short, stubby legs, like Dachshunds and stuff, where there are genetic mutational changes that weren't there in the wolf gene pool, but those are losses of information. Like, the reason why they have short, stubby legs is because they don't grow legs properly. Their cartilage is mutated. And so they have a loss of information that makes them so they cannot develop fully. And so it's a removal of information from the original gene pool.
Not the addition.
Not the addition of new information that wasn't already there. So you can like cave fish without eyes. The original fish had eyes, but you can make a tiny little point mutation, and all of a sudden the offspring fish no longer have eyes, right? So you can change the appearance of a creature by removing information, but most of the time, additional information is not needed to explain, certainly not for dogs or breeds of cats or anything like that. It's all Mendelian.
Okay, so let me just put you right on the spot then, Sean. Can the Darwinian mechanism, the evolutionary mechanism of random mutation and natural selection account for the incredible diversity, variety of biological life that we see today?
No, because there turns out that there are limits. These kinds, these gene pool kinds described in the Bible, they have discrete limits where, as the Darwinian mechanism, random mutations, as you start mutating the DNA, you can make it from island to island within shortly spaced islands. Like, I like to use Scrabble boards with 3-letter words.
Okay, do you have a slide you want to put up to that effect?
Let's see if I can make this thing work. So yeah, let me see if I can get that up for you. Can you see my screen?
Yep, I can see it.
All right, let me go over this with you. It's called sequence space. Can you see that?
I sure can.
All right. So here's the sequence space. What happens is that sequence space is defined by
Now, just quickly, Sean, you can't see this if you're on Instagram Live, but if you're really interested in this part of the talk, all of this will be captured and then uploaded to my YouTube channel in a few hours. So if you can't see it, that's okay, but you will be able to see it. So go ahead, Sean.
Okay, sequence space is basically a space that contains every possible permutation of a sequence like 3 letters. Every possible arrangement of 3 letters is for 3-letter sequence space, let's say. And it creates a checkerboard of different options. Like the whole space of all possible rearrangements of 3 letters creates a certain size of checkerboard.
Okay.
And as you move up, you get higher and higher, bigger and bigger checkerboards that are exponentially bigger.
Okay.
And so when you're trying to get from one 3-letter word to another 3-letter word, it's pretty easy. You can get from cat to hat to big to dog by just skipping around, changing 1 letter at a time.
Mm-hmm.
And you can get to another meaningful English word.
Okay. Like cat and hat, bat.
Yeah, they're only 1 letter away, right? One little step away. But so I started thinking to myself, what happens if you move to higher level sequence space? Like what happens to 4-letter words or 5-letter words? Is it just as easy to mutate between one and the other, right? So here's a example of ratios. What happens is that ratios change exponentially. So what's the ratio of defined 2-letter words in English versus the total size of sequence space for 2-letter words? The ratio is 1 in 7. So it's pretty easy to evolve in short amounts of time between 2-letter words, just doing one step to another, right? But the ratio changes to 1 in 18 for 3-letter words. But when you go to 7-letter sequences, and there's not just single words, you can have sentences and multiple words as well. The ratio is 1 in 250,000. So
so let me just pause you right there, Sean, to make sure that everybody's understanding that. So if we just randomly assembled 3 English letter, we're doing this in English, so just 3 letters from the English alphabet, and we just throw one down, and it says H, and it says A, and it says T. That's hat. That's a meaningful sequence. But there we go. Oh, very good. Okay, why don't you explain it?
So I tried to illustrate this with my Scrabble board, right?
Okay.
So if I threw out letters like randomly and they land like that, who would doubt that my story that I just threw those out and they just happened to land like that? Who would doubt that?
That seems totally reasonable.
That,
I would believe you. Yep.
You would believe me, right? Most people would, right?
Yeah.
But now, what if you look at some arrangement like this? Would you believe me now? I just threw them out. They happen to land like that. And there's a bunch of words there that are in English, right? Pig, cat, car, fur, whatever, right? Now you're like, well,
it's possible, but it seems a lot less likely.
Maybe if you threw it out a couple hundred times, this might happen occasionally, right?
Okay, gotcha.
Now, what happens now? How many people would believe I just threw this out, 3 or 4 times, and it just happened to come up like that, right?
Just some amazingly dumb luck.
Yeah.
I don't believe you, Sean. I know you as a person of integrity and a Christian person, but I don't believe it.
Yeah, but a lot of people can't explain why they don't believe it. They just know it intuitively that doesn't make sense. But mathematically, why doesn't it make sense that I just threw it out there and it lands like that? Well, it's because of sequence space. The odds become exponentially harder and harder and harder when you move up a level in sequence space to find the next beneficial island in that sequence space.
And by island, you mean a meaningful sequence.
A meaningful, beneficial sequence. Not just meaningful, but if you're talking Darwinian evolution, it has to be not only meaningful, like makes sense, it has to be beneficial, more beneficial than what came before. And so what happens when you move up a level, those islands become farther and farther apart linearly, right? And so in Darwinian evolution, to make it from one island to another island, if the distance increases linearly, what happens to the time necessary to make it from one island to the next island?
It would have to be exponential almost.
And what happens is that you have to do a random walk because the walker, the random mutations, random means blind. They're random. They can't see where they're going.
It's not being guided by God. It's not being guided by some other superintending
there's
agency.
No intelligent being here. It's random, right? So random means that you have a random walk. And so you're just wandering around blind, these random mutations, this walker, trying to find another island, but it doesn't know where it is. So it's wandering around blind. And so the distance that it has to walk, the average distance that it has to walk to get to a next beneficial island on this checkerboard increases, the distance increases exponentially.
So just let me kind of explain that a little bit here. If we throw down 3 random letters from the letters in the English alphabet, there's a reasonable chance, a 1 in 18 chance, that we'll have a word. But if we go, let's say we're going to try for an 8-letter word, and we just throw down, random letters, the chances of that, okay, there's a 7-letter. Our chances suddenly go to 1 in 250,000.
Right. And
this is the point.
It goes up into the trillions really quick. Right. And so when I started looking at the same thing happens with proteins, but it's because proteins also are characters. They're based on a 20-letter alphabet. English is 26 characters in our alphabet. Proteins have 20 letters in their alphabet, right? DNA has four letters in the DNA alphabet.
Okay.
And so when I started looking at that, I was like, how many mutations or what level are we talking about here for when we get examples of evolution in action? How many proteins, how many letters are involved, right?
Yeah, how many letters?
Yeah,
we're now using the proteins. The letters are an analog for the proteins.
Right, and proteins have their own letters. They're called amino acids.
I was going to say proteins are made up of amino acids. So how many letters are in a protein?
Yeah, there's 20 different amino acids, right? And so when I looked at real examples of evolution in actuals, like novel enzymes evolving, I was like, what's the size of that enzyme? What's the minimum size of that enzyme?
Okay.
So, well, they're all less than between 100 and 200 amino acids. Nothing goes over that.
Okay.
So there's nothing that evolves in literature, in scientific literature, so I draw my line at 1,000, because if you sit down and do the mathematics for what would it take to evolve anything new that requires a minimum of 1,000 specifically arranged amino acids in sequence space, how much time would that take? And the time it would take at the 1,000 amino acid level is in the trillions of years. Trillions and trillions and trillions of years, which is longer than the age of the universe. So statistically, it would be extremely unlikely for even one such event to ever happen within the beginning of time.
But the idea is that this happens with a kind of facility and rapidity that it's just happening all around us. It's easy, right? But you're saying
for Darwin evolution to have to be true, within 4.5 billion years to get from there till now, this would have happened trillions and trillions of times, not just once, but trillions of times at a level far beyond 1,000 amino acids. I mean, we're talking extremely complex beings, like even bacteria, like a bacterial flagellum, requires 40 unique different proteins and specific arrangements that require at least 5,000 specifically arranged amino acids. You don't get anything like that evolving in real time. You can't see that. There's been no laboratory demonstration. Statistically, it's just impossible. And that's just one machine in one little bacteria.
Right. So Sean, question about that. You have presented this, what you regard as a fatal, fly in the ointment of the whole notion of Darwinian evolution. You've presented that to people that are absolutely committed to Darwinian evolution. What's the response? You say, hey, look, the mechanism can't do what you say it can do. The sequence space is too big and we don't have enough time to do it. They say what?
Well, most of the time, when I'm talking to a regular person who's committed to evolution, they usually say that they can't explain it, but somebody else can. They know somebody else must be able to explain it.
Isn't this the argument from authority? Or some version of the argument from authority?
There must be somebody who can explain it. Otherwise, somebody would have figured it out by now. So there must be somebody out there. But there's a lot of other people that are coming up with this who are deeper into the scientific understanding and mathematics even than I am, who, like you interviewed Bosman, and he brought up some of these guys already who are famous synthetic biochemists, who are famous mathematicians who also say, yeah, this doesn't happen in real life. And statistically, it can't happen. So there's some, and also when I did debate, like there was a mathematician, he's a mathematician and he's committed to evolution. He's even written a book against creationism called Among the Creationists.
Okay.
And
you debated, didn't you debate him on like a radio show or something?
I did. So he was telling me, well, mathematically, it's perfectly fine because all you have to do in sequence space is take these little islands and line them up so that they make a little stepping stone line across Lake Superior, and then you could just easily walk across.
Gotcha.
And I was like, yeah, that's absolutely correct. You could do that mathematically, but what does it look like in real life? How are these islands spaced in real life sequence space, right? And they have a random distribution. They're not lined up in a nice little line. They're just randomly distributed in sequence space. And so I was like, it wouldn't work when it comes to real life proteins and DNA. That doesn't happen.
Yeah, because it's not like, in a given matrix, you don't just have the amino acids or the proteins lining up nicely. Oh, no, that combination didn't work. Let's try another one. I mean, they're distributed randomly in three-dimensional space. How do you get them together?
Yeah, you can't unless you have an intelligent mind. Like Jason Rosenhaus is the mathematician's name who I debated. I was like, you can imagine this because you can make leaps of logic to the next island in sequence space. You know how to get there because you have foresight, right?
Right.
Random mutations are blind. They don't have this foresight.
There is no superintending benevolence that's guiding this process.
Right. And so if the island isn't artificially, like it's like stacking the deck, you can stack the deck because you're an intelligent mind.
Right.
You know how to stack the deck and put all the aces together. You can do that because you're an intelligent mind. But if you have random mutations doing that, there's no stacking the deck. You can't artificially do that.
Yeah, the word random means something.
Right. And if your solution to this problem isn't random. Right? So he got really frustrated with me.
A question about that, Sean. You just touched on something there that maybe you could just, I'm just going to ask you a question about it. So we're dealing here with what amounts to information, right? I mean, that's kind of what the discovery of DNA revealed to us, is that in the same way that English letters like cat, hat, dog, dig, these are sequences that contain information. They're symbols that point to something. Where is the source of the information that is contained in the amino acid sequences of DNA? Where do we get where did the information come from?
This is really a bizarre question because all sources of information, meaningful functional information that make interacting machines or interacting language systems, anything like that we know about, always has an original source in an intelligent mind. Right? There is, like, let's say you go to Mars. Our Mars rover happens to come across like a highly symmetrical 3-meter granite cube that's polished, perfectly symmetrical. Well, that requires information. And that would hit the front page of every newspaper in the world saying, wow, this is proof of intelligent aliens outside of human.
No one would say, wow, look at how the elements of the universe shaped this rock into a 3-dimensional 1 meter by 1 meter by 1 meter cube, perfectly polished. We would just know instinctively, hey, that was created. That's designed. Is that the point?
Yeah.
And then we would say that would have to be an intelligent source that did that.
Right. And so the same thing happens. People get confused about information language systems because they just assume, because of Darwin, that language systems are more malleable, that they can easily mutate from one system to another and make complex machines, whereas inanimate objects like granite cubes don't happen by themselves, right? But the same information problem happens with complex machines as it does with granite cubes. The same statistical problems happen in both scenarios. It's just that people have been blinded by thinking in a Darwinian way to think that it's possible given enough time. But even given billions of years on Mars, you would never get a highly symmetric polished granite cube with random lightning bolts striking the surface. It just doesn't happen with random. It gets worse. Time is the enemy, actually, to informational complexity.
Because things are degrading.
Time and entropy. This is a law of science. The law of informational entropy degrades information over time. It doesn't improve over time.
Okay.
And that's one of the most solid laws of science that there is, informational entropy. And yet Darwinian scientists and evolutionary biologists and secular scientists in general think that they can somehow get around this law of science.
So when you're talking about informational entropy, this is the loss of information, right? Like
Right.
it goes back to the Dachshunds, the dogs that you were talking about earlier. They used to have longer legs that were more functional, but then information is lost and the leg is compromised.
Right, or flightless birds on windy
Flightless
islands.
birds or blind fish.
Yeah, they all lost information. So things tend to homogenize and decay into kind of an even homogeny if you just leave them to themselves without additional informational input. And so,
And the only known source of information that could sort of reverse this informational entropy would be a mind of some kind.
right, and so it actually suggests an origin in an original mind that's eternal. And the only way around the only really way around that concept is that physicists have come up with an idea to really get rid of God. And the only way you can explain the complexity of the universe that Bosman talked with you before, or the complexity within living things, which, by the way, the simplest living thing that we know about is more complex, informationally speaking, than the whole universe.
Okay, wait. Say that again. Say that again a little more slowly.
Like a bacteria, a tiny little single cell organism has enough genetic information that's more mathematically complex. Like it would take more intelligent input, mind power to create that tiny little bacterium than it would to create the fundamental laws that govern the whole universe. That we know about anyway.
I read a book years ago that said that every cell in your body is at least as complex, not as the car that you drive, but as the factory, the robotic factory that made the car that you drive. Is that true?
Maybe, I think it's even more than that. I think it's like complex as a city, like a metropolis.
Okay.
It's got so much going on. It's got tiny little robots all over the place, all kinds of different ones. They have two little legs walking along pulling stuff. It has little cars inside of it. It has little crawling machines that crawl along these cables to take things to different places. Even the energy system of a cell, based on the mitochondria. The mitochondria crawl inside the cell like little crawling robots to different parts of the cell that need more energy. And how did they even know that part of the cell needed more energy? They had to have another robot tell them, hey, crawl over here. We need some more energy. It's amazing how complex even the single cell is.
So a single cell is almost incomprehensibly complex. And then in order to make a multicellular organism, like say, a worm, or even more complex, a mouse, now, aren't we just off the charts in terms of the kind of complexity that the human mind can even understand?
Well, it's beyond us because we haven't made anything close. We haven't even made a single cell.
Fair point. That's a fair criticism.
Science. Yeah, and so what it suggests is that there's an infinite mind, and the only way to get around this that scientists have come up with, like Lawrence Krauss, he basically wrote this book called A Universe from Nothing. The whole goal of secular science is to explain how everything came from nothing. I mean, nothing. And so what happens is that they believe that there's this giant quantum computer, and it created a quantum pond that's bubbling. And every little bubble is a new universe, poof, popping out of nothing, but not really nothing, popping out of the information that this quantum computer generates. And the computer generates all these potentialities. And every now and then a new universe pops out infinitely. So what happens is that this quantum computer becomes God. It can create anything and everything because there's an infinite number of universes. So the complexity of our universe just happened to turn out right.
Right.
Because if you have an infinite number of universes, it's eventually Arnold Schwarzenegger is going to win the California lottery 500 times in a row. So
a question about that. What then is the distinction between God, as we know him and understand him, with an infinite mind and possessing as he does omniscience, omnipotence, etc.? How do we differentiate between that and this quantum computer that's being posited?
Yeah, there's no difference except for that God can judge you morally.
Oh,
right?
Okay.
Right? So the quantum computer doesn't judge, it just is. Right. I'm sorry. I just, one of these universes that popped into existence. It wasn't planned. It was random. Right.
Right.
But if you believe that God did it, who's an intelligent mind, and he deliberately made you to do certain things and be a certain way, well, now you have moral responsibility. all of a sudden.
There's accountability.
What's another problem with this multi-universe theory is that it removes the basis of science. There's no predictive value for any scientific hypothesis, because some universe somewhere it's bound to happen. There's no random chance anymore. I mean, you can't doubt anything anymore. You're like, well, I don't believe you. I think you're cheating on that card game. I don't think you really had all those 4 aces, right?
Right. I use that illustration with Anthony.
Right. The last 8 games, you had 4 aces every time. Come on.
Right.
Right.
Okay. Now let me ask you about that. Let me ask you about that. Switching away from the multiverse idea, which we talked a little bit about with Anthony, this is the problem of, biogenesis, right? Where did life come from originally? And is the secular answer to that, well, we don't know, but we don't have to know? Like, we don't know the mechanism, because Darwinian mechanism, like the laws of grammar, only work when you actually have letters and words and communication. Darwinian evolution can't really get off the ground until you have, an assortment of cells and amino acids and proteins to actually get the thing going. So what about life? Where did we get life from? And can Darwinian evolution be used to get us to that first cell, or no? Or even that first amino acid? Because
before there's life, there's no natural selection. There's no preferential selection, right? There are random mutations, but there's no preferential selection. And the idea is that, life could have come about because we've seen lightning bolts strike some sludge in a petri dish and create some amino acids. So, clearly life can evolve because we can create amino acids randomly with random lightning bolts or electrical currents or whatever. And it's like, it doesn't matter. You can have all the amino acids you want in any kind of petri dish that you want, and you still won't make even the simplest living thing. There's the letters randomly distributed on your Scrabble table. You could shake the Scrabble table for trillions of years. You're not going to make the works of Shakespeare by doing it that way.
This was the famous Mille-Urey experiment, right? In the 1950s, where they thought, we'll just sort of shock a bunch of amino acids, and then we'll create proteins, and then they'll just walk us through that experiment. And did it prove anything?
Yeah, they made a few proteins that way. And so they just made a leap of logic saying, well, because we made a few proteins, and somewhere, sometime in some warm pond at the beginning of the world, this could have gone farther. We don't know how it went farther. They're still working on that. But statistically, it's just never going to happen.
Is this still the secular explanation du jour for the existence? So this is it, the warm pond, the lightning striking the warm pond.
Yeah, maybe some clay. They think, if we have just a proper clay that brings these things together, and if we just have the proper lipids at the right time, that can bring it together. But
shouldn't we be able to recreate this? I mean, if it could happen randomly, shouldn't we right now there's like 100,000 engineers that work for Google. We have so much mental power, so many smart people in the world, scientists and others. Shouldn't we be able to pull this off?
We can pull it off to a certain degree. Chemically, there's synthetic biochemistry, and you can create some pretty complex stuff, even some really complex machines that interact. Like, they even make little race cars. They do the Tour de France on a tiny little 1 centimeter of gold that would be like going around the world like 3 times, based on the size of these tiny little molecular cars that they make.
Okay.
But the problem with these little cars and these complex machines that they make biochemically is that it takes an intelligent mind.
I was just going to say, isn't the point here that it takes a mind to do it?
Right. Because randomly speaking, the chemistry just doesn't happen. Time is your enemy when it comes to biochemistry, and synthetic biochemistry especially, because as soon as you make one little tire on your car and then you try to add the other little tire on there, if you have 1 million years in between, this tire that you already put on there will fall off.
Fair point. So this is back to that informational entropy and just general entropy, right? Like, who holds the thing in place long enough for, this, like you say, this car with 1 tire to get the next tire?
Right, exactly. And that you can't do it unless you have an intelligent mind and say, no, we cannot lose this tire in the meantime while we're trying to put this other tire on, right?
Okay,
That's
so
directional.
Go ahead, Sean.
That's directional, and having a direction requires vision of the future, right?
Foresight.
Foresight, and only intelligent minds have foresight that's necessary to do this.
Okay, so let's move off of, just at least for the time being, off of random mutation, natural selection, informational entropy, and the limits. Let's move off of that. Let's talk about the flood. I want to talk, in this chapter here, the literal week, which we went over with Dr. Bosman. I just want to ask you, is it plausible to you, as somebody who's very scientifically minded, you're oriented to saying, is this actually believable? What did you find with regards to the flood? Is there evidence? Is there reason to believe that there was, in fact, a global flood? Or was this just like a regional flood that was perceived as global because it was so massive to them? Talk to us about the flood.
Yeah, that was my second thing. So I got really excited when I figured out the genetic part. And I started sharing this with my military friends, and they were totally shocked because they'd never heard anything like it at all. And they're the ones to help me set up my first website and do all this stuff. Okay. And so then they started moving on. It's like, well, genetically speaking, now we know the mechanism doesn't work. So what about the flood? What that's got to be totally like legend, right?
Right. It's a fable.
It's a fable. You got to at least admit that one, Dr. Pitman, right? And I was like, well, I don't know. Let's take a look at it, right? I got you on the genetic part, so maybe the flood part isn't so fable-ish.
Okay.
Right. So I started looking at that, and that took me a little longer. That took me about a year or so, because there's a lot of misinformation on the creationist side, dealing a lot of hoaxes on the creationist side that are just not true, arguments that are bad. And so it took me quite a bit of time to sort through all that. And to find which arguments are good, which arguments are bad. And so I did come up with things that for me made more sense.
Okay.
I'll just share some pictures.
Oh, you're going to put your screen back up again?
Yeah.
Okay. I'm going to pull the Instagram here. Okay.
Let's see if I can get this thing to move along. All right. It's going here. All right. I'll get past the Scrabble board.
Yep.
There's my molecular machine, one of them.
Okay.
That was synthesized, but with an intelligent mind. And I'll get David Galertner, all these guys. All right, here we go. So what really struck me when I first started looking at this was the Grand Canyon and how flat the layers were in the Grand Canyon. And I started thinking to myself, if this was the surface of the ground, each one of these layers was the surface of the ground for millions and millions of years, how in the world did all the layers become so flat? Why they should have been eroded every time they're the surface of the ground. All the surfaces should be up and down and undulating if they really truly represent millions of time of Earth history, right? And you can see at the top layers, they're completely eroded off. And even the erosion where they're completely removed, they're eroded flatly.
Okay.
It's like, how do you remove layers and layers and layers so evenly and so cleanly and flatly like that?
Because if you've traveled to some of these places in Nevada and Utah and Arizona, I mean, it just looks, it's almost razor-like sharpness. I mean, was that the surface of the Earth for millions of years? This like pool table flat? That's the question, right? Right.
It should look more like this, where as you erode one layer and then another layer comes in, then you erode that layer, you get to the number 4 sequence where it's kind of all mixed up and undulating, right? That's what you would expect if Darwinian evolution were true, but that's not what we see in real life. So that really struck me. And then you actually go up and look at it really closely. Like you said, it's like a razor blade that lines these things up. And you're like, how do you explain that from a long age perspective? And then it just goes on from there. You have footprints that only go uphill in the Grand Canyon. And you also have these on top of every surface there around the Grand Canyon. You can see these ripple marks that can only be created by water. They're divergent ripple marks. You can see them at the beach when you go to the beach.
Yeah, I've seen these many times.
V shapes. That's all over the place in the Grand Canyon. And then you have to know that the actual sand in the Grand Canyon, some of the entire layers, like the Coconino and Navajo sand dunes, all of the sand came from the Appalachians, clean across the continent. And you're
really?
Like, Well, how did it get all the way across the continent over millions of years? Right?
How
and
do we
it turns
know
out-
that that sand came from the Appalachians?
Because they can test it chemically and it matches the Appalachians.
Okay, gotcha.
So they know it came from the Appalachians. And so the question is, how did it get from the Appalachians? What's also really interesting is Arthur Chadwick from Southwestern Adventist University. He went and on the surface of these layers, he tested these ripple marks to see which way the water is going. And for a given layer, all across the whole continent, it goes in the same direction. Like all over the place. So it's like a huge sheet of water went shoof all the way across the continent and carried the sediment all at once, all the way across the continent and just deposited in Arizona. You know, so I thought that was fascinating too.
So Sean, can you sort of give us give us just a really simple explanation as to what happened in the flood? Because I've heard you talk about before that some people have this picture in their mind, kind of like the bathtub model, right? Like you start filling up a bathtub and it just gradually fills up. And that is not the picture that's described in Patriarchs and Prophets in the flood. It's not what's described in the chapter after the flood. So can you spend a few minutes sort of unpacking for us what you think Scripture describes and what the science suggests actually happened in the flood?
Yeah, because the Bible describes, it says, in a single day, all the fountains of the great deep were broken up in one day. Boom.
Right.
So to me, that sounds like a huge catastrophe, like an impact, like a giant asteroid or meteor hit the earth, and a huge one, and just broke the earth up like an eggshell, cracked it all over the place, and shook it like a bowl of jelly. Even the tilt of the earth, it got tilted 23 degrees. I mean, it got hammered. And we can like a third of the Yucatan, the Gulf of Mexico is an impact crater. We know that these giant asteroids did hit the earth and make these huge craters. And here's a picture of one. If one of these things hit the earth so much that it broke the whole earth.
This is an actual picture, this one on the bottom?
No, well, this is an illustration of what actually.
Oh, gotcha, illustration.
Yeah, of what happened in the Yucatan. Where
Gotcha.
this impact crater, when it hit, it would create a huge tidal wave that would be like 2,000 feet tall. And it would travel around the whole world like, you know, at the speed of sound, 500, 600, 700 miles an hour. And as it went over continents, because Ellen White says that before the flood, that there were no great mountain ranges. It was pretty flat, relatively speaking.
Right.
Rolling hills and everything. So a 2,000 foot wall of water would completely swamp the continents that existed. And it would go whoosh. It would start at the impact and it would go around the whole globe in a circle, like a bathtub. But since the world is round or a circle, like a sphere, it would go around like a big circle. It would go around and around until it got to the other side. And it would hit itself and bounce back and go back around the other way. And boom, boom. And if you have multiple impacts all the way around the globe, you got all these huge tidal waves going around back and forth all the time, like a giant bathtub. So what happened is that initially when the first waves hit of these giant tidal waves, they would sweep across the whole continent, and the dinosaurs would survive the initial impacts because we have the footprints for the dinosaurs and everything on the mud, and we have their preserved footprints all over the place. And so they survived because we know that the footprints evolved before the dinosaurs. Didn't you know that? In the lower layers of the fossil record, there's footprints but no bones for the dinosaurs.
Is that true?
That's true. That's Arthur Chadwick showed that as well. The lower down you go, the less bones and the more footprints, right? So what happens is...
Which would make sense if things were trying to flee from rising waters to higher places.
Higher elevations, and they survived at first, right? So they made it through the first wave. The first wave would come, and then it would expose the ground for a while because the wave would disappear. You know, it keeps going around the world, right? And so the dinosaurs are able to walk around, but every wave that comes back, the dinosaurs get tireder and tireder, more tired, and finally they give up and die. And so that's where the bones are, up on top, on the higher level layers for the dinosaur bones. And even the eggs, we know that during the flood, the dinosaurs were all around the whole world under extreme stress, because when a chicken lays an egg, how many layers does the egg have usually?
I don't know.
Just one layer.
Okay.
Chicken shell around the egg.
Gotcha.
But when you when you disturb the chicken and play rock music all night, don't let it sleep and keep harassing it so it can't lay its egg in peace. Well, it keeps the egg inside of itself, and it adds more layers to the egg.
Interesting.
More and more layers of shell.
I didn't know that.
Yeah, when the chicken is stressed, it doesn't feel comfortable. It says, well, I can't lay my egg now. I might die at any moment, right?
Okay.
I have to, it's fight or flight, right?
Okay,
And
gotcha.
so it keeps the egg inside of itself and adds more layers of eggshell to it. Well, all around the whole world, everywhere that you find dinosaur eggs, they all have multiple layers of shell. And so it means that all at the same time, it's like, were dinosaurs stressed out for millions and millions of years? All the time? Like, no.
High stress life being a dinosaur.
Yeah. So it only makes sense that they were stressed out by some global catastrophe that affected the whole globe at the same time, all around the world. And I have pictures of that too.
Okay. Pictures here.
Also, the erosion rate, we can get back to that. The continents still fit, and yet they're supposed to split apart 200 million years ago. They shouldn't fit anymore. Yet
okay, go back to that, Sean. Just quickly, I want to come back to the eggs. But make this point, it's a really good one. You're saying that the continents, they actually fit together. This is sometimes referred to as Pangea.
Right.
But if the Earth is reported, 4.5, how old is the Earth supposed to be? 4.
Well, they're supposed to split apart. Pangea was supposed to have split apart 200 million years ago.
Okay, 200 million years ago.
But the
and you're going to say that the erosion rates...
The coastal erosion rate is way too high. It's enough erosion to erode 2,000 miles within that same period of time. Okay. On all edges of all continents. So you'd be basically in North America left with a little dot in the middle. Right? So not only would the continents not look like this, they certainly wouldn't fit together like a puzzle over this period of time.
Okay,
so
that makes sense.
Possibly be 200 million years there. Well, here's another picture of the water breaking up. Ellen White describes it like huge geysers and sheets of water shooting out of the earth, taking up massive stones way up into the air, hundreds and thousands of feet into the air, and then destroying everything when it came down. So it wasn't like a bathtub filling up gradually. It was a catastrophe. And there's also enough water to in the earth crust beneath our feet to fill up 3 oceans worth of water. So it's not like there's not enough water to swamp the planet.
So this is what's being described when it says the fountains of the deep burst forth and the windows of heaven were opened, right? Like there's an astonishing amount of water below us.
Yeah, huge amounts, way more than all the oceans of the world, at least 3 times as much as contained.
Okay, so back to those, were you going to say more about the dinosaur eggs? So the point is that there was a flood coming. There's a flood rising. They're under stress. They don't feel comfortable laying their eggs. And so that's why you have layer upon layer upon layer in these dinosaur eggs. Am I getting that right?
Yeah, you have double layered eggshells everywhere around the world for these dinosaurs. Also, a lot of these dinosaur nests, they were laying the eggs while the flood was rising, while the mud levels were. Here's one nest where you can see that the eggs are at different levels in the nest. So what was happening is as the mother was laying this nest of eggs, more and more mud was coming in. And so as she's laying it and turning around, laying the eggs, they get higher and higher and higher level of eggs until the mother has died and the egg is complete. The nest is completely covered over. So she's laying this in the middle of a flood. So I just
close that door, Jim, if you don't mind. Okay, so about that, Sean, I want to go back to the actual geologic column. I want to talk. Were you going to say more about that?
Oh, here's just a graph from Leonard Brand and Arthur Chadwick showing that the footprints are lower than the actual fossil bodies of the dinosaurs. And so this was published back in 1982. So we've known this for a while. It's just that no one talks about it. I just think it's fascinating, though. So
back to the sort of geologic column there, Sean. So the idea is that the reason that we see... Let me see if I'm still live here. I think I'm still live. The reason that we see give me one second. When we go, for example, to the Grand Canyon and we see that flat, like we were talking about, almost razor-like flat, the sort of traditional idea is that was ostensibly the surface of the Earth for millions of years, but you're saying that doesn't make any sense because the Earth doesn't look like that now. It's undulating and it's up and it's down. So is the idea that one of these large waves would come by in the flood, and it would just flatten everything out. And then it would start to dry a little bit and flatten. And then, oh, here comes another one, and it deposits another layer of sediment. And then it deposits another. Is that what's happening? And this is what's taking place during the receding of the waters, right? And it's taking weeks or months?
Yeah, because we know that Noah was in the ark for a year, right?
Okay.
And so evidently it was calm enough for him to, maybe not completely calm everywhere in the world, but calm enough for him to get out of the ark. But it took a whole year, for the world to have calmed down enough for him to even get out of the ark. So all these tidal waves and these massive impacts and catastrophes were happening all over the world for at least a year. So, and what's interesting too about this whole flood thing and the flood story is that when Noah did get out of the ark, the world was a very different place even than it is now.
Ellen White describes that. She says it was just total confusion. She says words can't capture what the world looked like when Noah came out of the ark.
Yeah, and he was shocked by it. And what's really different about it then than it is now is that the flood gave off a lot of the energy. So the world right after the flood was very warm. There were no seasons. It was very warm. There were no ice caps either.
Okay.
For at least 400 or 500 years after Noah came out. So that made enough time for all these animals to diversify all around the globe. And even up into the Arctic regions, there are millions of mammoths and lions and saber-toothed tigers and deer and bison and all these things that are frozen there, preserved there now, millions of them. In fact, the biggest export of Siberia, one of the biggest export, is ivory.
But it's not from elephants, it's from mammoths.
It's from mammoths, yeah, that are frozen there. And so they all got killed off within a single season. All of a sudden, all at once, within a single season, volcanoes going off all around the world, spewing up
ash
and sulfuric acid to block the rays of the sun. All of a sudden, that built up to a tipping point where in one season, you have an ice age. Bam! And it froze them all, and they all died together, even with chewing buttercups.
Yeah, I was going to say, aren't there like instances where they're like chewing food or giving birth? Like clearly they were frozen like instantly.
Yeah, really quick anyway.
Okay,
and,
maybe not
bam.
instantly, but quickly.
Yeah, caught unawares completely, and not enough time to escape for sure, because there are millions of them that were trapped there, and that all happened at once within one season. And so then the ice age happened, and what happened during Abraham's time, he describes, like in the Bible, that the Middle East is a land flowing with milk and honey. And I used to always wonder about that as a kid. I was like, well, you got to be kidding me. The Middle East is a big desert, right?
Fair point. Fair point.
But we know that the whole Sahara Desert was a big garden area, lush, verdant, had a giant lake there with tons of animals, lots of people living there. It was a very different world during the time of Abraham, because what happened is when the ice age hit, it hit on both sides of the planet. And so you have ice building up. New York City, where New York City currently is, was covered by 2 miles of ice. And so what happened, the whole world is covered by ice, except for a tiny little green spot in the middle, all the way around. And so that green spot is very green and lush, not dried out, because all the water is all around it in the ice, and it's keeping it all cool. It's not too hot, not too cold. The Middle East really was a garden area flowing with milk and honey for quite some time, until the ice started receding, and then things started to dry out. And that's why we're so different now than it was right after the flood.
So the period, the Ice Age period, is taking place not, are you saying several hundred years after the flood?
Right. There was no ice right after the flood.
Is there enough time for the diversity of, not just the diversity, but the distribution and distribution of the animals that we see on the planet today? That would have had to happen pretty rapidly, right? Just in a few thousand years.
Yeah, no, and it can. I mean, even a turtle, you think, well, a turtle only it can't walk around the world. But if you say, well, let's say a turtle moves a mile a year. Well, it can get around the world pretty quick within a few hundred years. The offspring will eventually get around the world, as long as there's a land bridge, right? And we know that there were a lot of land bridges before.
Hmm.
Like, you have the Alaskan land bridge that was before the water filled up and covered the land bridge, before the ice melted. Then it was a true land bridge. And that's how the American Indians came over, the Eskimos and the South American, everybody crossed that land bridge. That's how it, and all the animals in North America that we know got here, they easily got here over that land bridge.
So the variation within a kind, to not use the word species like we talked about earlier, that must be able to happen quite rapidly.
Very rapidly. I mean, you can see such extreme variation in dogs in just 300 years.
Okay, fair point. Yeah, that's a good point. We talked about that. You're saying
and like llamas,
Chihuahua
for example,
to Great Dane within 300 years. Go ahead.
You know that llamas in South America and camels in the Middle East, they can still interbreed and produce viable offspring.
Is that true?
There's a camma, yeah. And yet they were separated. They could, my argument is they could not have been separated for millions and millions of years. They have to be a recently divergent kind in order for them to still be able to breed and produce viable offspring.
Now, Sean, just before we went live, you were telling me about these two individuals that have put forward this idea. I think it was based, I could be totally wrong about this part, but the mitochondrial DNA, suggesting that everybody kind of appeared at the same time. Do you remember this, what we were talking about?
Yeah, let me see if I can pull that up.
Okay, let me grab my phone here and put it back on.
Thaxton.
Does that fit in here? When you said when we were talking about the distribution, okay, here we go. Is this what it is?
Yeah. So not too long ago, 2018, so just a few years ago, these scientists, Stockel and Thayer, put out this paper based on mitochondrial DNA evaluation to test out how closely related species were or species groups were. And based on the number of mutations, you can tell when they came into existence on the planet. All right. So what they came up with was shocking to them, not just to creationists, because we kind of suspected this, but especially to Darwinian evolutionists, which they are. So it was especially shocking to them that they concluded that based on mitochondrial DNA, that all species living right now, or almost all of them, came into existence at the same time. They said almost all species on Earth today emerged about the same time as humans. This conclusion is very surprising, and I fought against it as hard as I could. Now, why would they fight against it? Because this is totally not predictable from Darwinian perspective.
It's radically out of harmony with the Darwinian view of the age of the Earth and the evolution of species.
Right. And they said this all happened 100,000 years ago, which even 100,000 years ago is completely inconsistent with the Darwinian perspective of hundreds of millions.
Yeah, that seems like a long time to us, but by Darwinian models, that's a second, that's a moment. And
so some people gave me a hard time about this, saying, look, it happened 100,000 years ago. So certainly the biblical story of creation can't be right. Your whole 10,000 year or 6,000 year idea can't be right. And so I was like, well, let me look at this paper a little more closely. Where did they get this 100,000 years from? And they based their mutation rate on the supposed evolutionary relationships between humans and chimps, right?
Okay.
But then there's new data that came out from human pedigrees. How fast is the actual mutation rate based on known human relationship, human family pedigrees?
Okay.
And it turns out that the mutation rate is a lot faster. And what that means is that the divergence happened a lot less time ago, right? The origin of all these kinds happened more recently than 100,000 years ago. And you're just like, well, how much faster? Well, if you sit down and do the math, the genetic mutation rate means that all these animals, including humans, showed up at the same time between 3,000 and 6,000 years ago. Now we're all of a sudden starting to talk a lot more biblically.
I was going to say that sounds decidedly biblical. Okay, so let me pull in another little piece of evidence here then, Sean. Is that why, remind me of the name of the lady that discovered I guess it's like cartilaginous tissue or even blood inside of fossilized, what's her name?
Schweitzer.
Mary Schweitzer. Tell us that story. That's an incredible story.
Yeah, that's that was another thing that gave me a lot of confidence, because not too
Are
many
you going
years
back to the
ago-
screen again?
Let's see if I can find it. Yeah.
Okay.
Uh,
I'll wait to pull down my.
Oops, I lost it. Let me share it again.
This is a fairly recent story, like in the last 15 years, 10 years?
Yeah, it was probably about 10 years ago. So Mary Schweitzer,
Okay, let me grab this.
so in 2005, and then 2013, 2020, when she found more and more stuff, not just soft tissue, but also proteins and DNA, fragments of DNA even, she found in dinosaur bones. And she was shocked because all the science up until that point said that this could not possibly happen. Such soft tissues would spontaneously decay even without any chemistry involved, just based on temperature alone, because molecules vibrate based on temperature. And just vibration, just based on temperature, makes the molecules fall apart, called kinetic chemistry. And so based on that, science had said that this could never possibly happen, and yet there it is. She discovered it, and she was shocked. She's like, how could this possibly happen?
Do you know the story of how didn't she like drop one of these fossilized bones or something? Do you know that story?
Yeah, she was trying to dissolve some of the bone in acid, and she left it in the acid too long, so all the bone dissolved, and she thought there would be nothing left. So, but when she came back, she noticed there was something there. So she picked it up and put it under the microscope, and I don't know if you can see these little blood vessels.
Yeah.
That's what she saw. She saw the soft tissue. It was still elastic. It still popped back into shape when she pulled on it.
You're
and
kidding.
She saw these little blood vessels with blood cells inside of them. Right?
And these are these from Tyrannosaurus Rex?
Not necessarily Tyrannosaurus, but every large dinosaur bone that she looked at.
But the idea is that these are 60 million years old, ostensibly.
Right, 60, 70 million years old.
And there's no way blood vessels are going to last. I mean, what's the upper limit for how long? I mean, you're a physician. How long can this last?
Well, there's been some, in fact, she got a lot of flack. Even recently, she's gotten flack from this, saying that this must be contaminant. It must not be real, because the science is so strong that even under freezing temperatures, I don't know if you can see this, but even under freezing temperatures, minus 5 degrees Celsius, that DNA strands should not be intact. Not even one base pair should be intact after 6.8 million years. And that kinetic calculations under temperate conditions, that DNA should not last more than 10,000 years in temperate regions, a maximum of 100,000 years in colder regions, just based on temperature alone. The same sort of limits. Proteins can last a little bit longer, but not much. Maximum 1 million years, and that's under freezing conditions.
So these bones are supposed to be, what, 60 to 70 million years old?
Right. And so there's no possible way, based on what we know about kinetic chemistry, that these soft tissues, much less the proteins or DNA within them, because it's not just like random proteins, like they're broken down completely. They're sequenceable hemoglobin proteins. They even give it an antigenic immune response specific to hemoglobin.
Unpack that. I've heard you say that before. This is so cool. Explain that, the immune response, the antigenic immune response.
So she took these red blood cells in the dinosaur bones, and she pulled them out, she isolated them, she purified the proteins inside of them to see if the hemoglobin was still intact. So she took the hemoglobin, the protein hemoglobin that makes up the red blood cells, she injected them into rats to see what the rats would do, if they would mount an immune response.
And they did.
And they did mount an immune response, and the immune response wasn't random. It wasn't just like, oh, something foreign. It was a specific immune response directed against hemoglobin. In order to do that, you have to have intact hemoglobin molecules that are dozens of amino acids in length in order to have your epitope that the antibody binds to intact enough for it to recognize it as hemoglobin.
So at any point, does a discovery like this cause people to begin to reevaluate their larger assumptions about the nature of the age of the Earth or the evolutionary evolution's capacity to explain things? Or is it just like, well, that's an anomaly. Well, that's hard to explain, and we just kind of carry on?
for a lot of people, let's say somebody isn't already devoted to evolution, to the philosophy of evolution. If they're not already devoted, like they just grew up in, like just believing it because it was taught to them in school.
Mhm.
A lot of those people, when they hear this for the first time, they are open to it. Like all my military friends, they all
Yeah.
converted. They all converted, right?
I love it.
They're all like, wow, we were never told this in school. This is amazing. This like blows their minds that there's anything
Right.
like this, right? And so they were like shocked. They're like, you have to publish this. And, why doesn't everybody believe this? This is so
Right.
obvious, right? But when you talk to somebody who's ingrained in it, who actually should know better, but they're attached to the philosophy of it, then they'll fight tooth and nail. They'll find some reason not to believe you, or find some argument to hang their hat on to say, well, maybe there's some way to preserve soft tissue that we don't know about. Maybe there's
Right.
iron fixation, like Mary Schweitzer comes up with, iron molecules could fix these proteins for longer. The problem with that argument is I'm a pathologist. I make formalin-fixed tissue. It degrades so that my antigens that I use to stain these things will not work after like 20, 25 years because I keep my tissue in like ambient conditions. I'd have to freeze it, right? And so iron just doesn't work. It doesn't preserve tissue very long in ambient conditions, and neither does formaldehyde. And so you're like, and also some of these dinosaur soft tissues were not exposed to iron at all. They're not hemoglobin. They're like in the horn of Triceratops, where there's no blood at all. And there's soft tissue in there that's well preserved as well. And so how do you explain that? And so they just try to avoid what I think is obvious. Also, these soft tissues have radiocarbon in them. That's the same amount of radiocarbon as in the mammoth that are frozen in Siberia. They lived according to radiocarbon, they lived at the same time, right? So
okay, so Sean, I'm going to put you right on the spot here. We've got to bring this particular session to a close, but before OT with DA is out, I know we had a little trouble organizing our schedules here, but can I get you back for a second session where we can take some questions and go a little deeper? We'll just work around your schedule. Are you up for that?
Sure. Yeah, anytime.
Sorry to ask you publicly, but I know you well enough to know that if your schedule's open, you'd be happy to do it.
Yeah, sounds great.
Well, listen, Sean, I just want to close with this, and then we will do a 2.0 session, and we'll get to some of these questions that we've got here. You talked about your journey, and you were trying to put all the pieces together. Do you feel like now, obviously you don't know everything, nobody knows everything, but do you feel very settled now, not just based on what Scripture says or what religious people believe, but just based on the evidence that you've looked into yourself, not just reading other people's books? Do you feel really good about the notion that what the Bible describes is exactly what happened?
Yeah, I feel a lot better. Like you said, I don't understand everything, certainly not about the flood, because it was singularity. You can't go and research the flood in a petri dish, or real time. But the evidence that I think I do understand is a lot more consistent with the Genesis account than with any sort of secular account over millions and millions of years. And I don't understand even all the features of the fossil record or geologic column. I can't explain all of it. But what I think I do understand about it is far more consistent with the Bible and the Bible's claims than it is with secular science.
Brilliant. Sean, thank you so much. You are a giant blessing, and blessings on you and your wife and your children. We will reschedule a time sometime in the next month or so. We should be able to find another 2-hour period, shouldn't we?
Sure. Yeah, I think so.
Okay.
Right.
Sean, thank you for taking your time. Thank you to all of those of you that tuned in on Instagram Live. This is part 1. If you want specific questions answered, I had actually several questions here. You can go ahead and put them in the comment section of the YouTube video that will be up under this video shortly. And Sean and I will sit down with our calendars. We'll figure out a time to come back. And thank you, Sean, for tuning in with us. And thank you to all of you that tuned in. And this is part 1, and we'll be back for part 2. Sound good?
Thanks a lot, David. I really appreciate it. A lot of fun.
Thanks, Sean. Take care.
You too.
Bye-bye.
Bye.